Hello, everybody. My name is Alexander Trentin from Finanz and Wirtschaft. I'm here based in Zurich from the offices of Finanz and Wirtschaft, and I welcome everybody to our today's webinar in our series Data-Driven Analytics. The topic of today will be smart farming, using data-driven analytics to improve agriculture. We have three very highly qualified speakers today to inform us of the developments in this sector. Before we continue, I would like all the audience to fill out the survey. You got a survey when you logged in into Zoom, and I would like to ask you to fill out this survey. There are three options. Question is, what is in your opinion the most important application of data-driven analytics in agriculture, if you have an opinion? The first one would be achieving better outcomes, achieve better harvest. Second, improving efficiency. And the third one, meeting demands of the market in a better way. We will discuss today how data analytics and artificial intelligence can be used in making farming more efficient and as well as achieving better outcomes. And of course, it is a very timely topic as there are huge environmental concerns regarding how we can feed humanity, which is in regards to an ever-increasing population, as well as the global climate is warming. So before we start with the presentations, I would like to ask to see the result of the survey. Let's see so what we got here is like there's a tie between improving efficiency and meeting demands of the market. And not as many people say that achieving better outcomes is an important part of data-driven analytics in agriculture. I would like now to introduce our three presenters today. First one would be Thierry Bücheler. He's Head of Innovation, Strategy and Operations at Oracle. Before joining Oracle, he was an engagement manager at McKinsey and a visiting researcher at NEC Tokyo. We have Ionut Deaconeasa. He's a solution architect at Intel's Internet of Things group. And before he worked as an engineer, before that, he worked as an engineer in the semiconductor and instrument space. And we've got Alexander Lehrmann. He's a senior director for innovation and development at the strategy and transformation department of Sunrise, the mobile network provider in Switzerland. And before, he was involved in building up the Internet of Things business at Sunrise. And previously he was involved in the corporate strategy at Swisscom. Thank you so much for joining us today. That will be a very interesting session today, I'm sure of that. And so for the audience regarding questions you might have, we have a question and answer window in Zoom. So you can ask during the presentations questions, you can type them in, but I would like to ask the presenters not to answer them directly in the question window, but to wait until all presentations were given. So we got all the three presentations. Afterwards, we have around 10 to 20 minutes for questions. And then I would like to discuss all the questions together. So we could have like some kind of where also the presenters could discuss about these questions. So please don't answer the questions during the presentations, but to the audience, you can ask all the time, at any time, you can ask the questions in Zoom in the window. Right, so without further ado, I would like to ask Thierry Bücheler to start with his presentation, and the topic of his presentation will be unlocking opportunities in agriculture through data analytics and what that might mean for you. Thierry, the floor is yours. Thank you so much for joining us today.
Thank you very much, Alexander. Hello, everyone, also from my side, and welcome. My name is Thierry Bücheler, as Mr. Trentin already stated, and I'm constantly aiming to understand the value of technology for business models and the public sector. Today, I will be focusing on agricultural sector, obviously, because that's the topic of today's meeting, and specifically some fields of application therein. However, I will make a link, because we don't only have agriculture specialists here today, to some of your industries and what that might mean to you. Now, the current challenges the agriculture industry is actually facing are not just for fun or only for money, but in fact, they go far beyond that, as we just had heard during the opening. And with the world population expected to reach more than 9 billion in 2050, as most of you have seen, the FAO, for example, predicts a 70% growth in agricultural output that is required to serve that projected demand. We also heard in the intro a couple of counteracting dimensions. You see some of those here. Now, this has greatly increased interest in, but also the utilization of data analytics in the agribusiness as a whole. A couple of years back, McKinsey published a study that sized the global food and agribusiness market at $5 trillion with a significant growth potential. In the same article, the firm investigated 24 promising investment themes that make the whole approach a bit more tangible. Now, there are several sources stating connectivity specifically, and even more specifically, the Internet of Things as the key enabler for most future-looking ideas. And I'm very happy to also later hear Mr. Lehrmann's presentation. Data and data analytics are, in turn, a key application enabler, of course, for IoT applications. Now, before we dive into the technology, for some of you who are potentially not experts, here's a quick overview for the agricultural sector. Now, let's look at it from a value chain perspective. I think that's easy to understand. We move from the inputs through production, then into post-harvest activities to further processing and to distribution all the way to consumers, of course, who need to be fed or need the materials. If we double click on the large field included in production, we find some obvious subsections, but also perhaps less intuitively associated fields like forestry and logging, as you can see, as part of the sector. And then further below, you find just a selection of technology topics concerning these parts of the value chain, including some overarching topics like smart buildings and equipment that obviously are not only relevant for agriculture. Again, many of those fields are driven by data and analytics. When broadening the technology view on agriculture, you see more traditional topics like platforms, customer experience solutions, both for the B2B and B2C space, of course, and also visualization as one interesting challenge. There is no large technology vendor, by the way, at the moment that dominates a field so far, even in those well-known topics that have large providers in other industries. On the other hand, there are some innovation topics, of which you'll also hear more from the experts presenting today, concerning more effective targeting and precision, which is a recurring theme, more sophisticated data handling, and potentially the overlapping field of autonomy. This list is not complete and also overlapping, and we will focus on data analytics today, which in fact touches many of the other fields as well. Now, advanced analytics are aiming for several goals, and these are actually not mine. I took them online, and typically if I have someone else's content, the source is given on the slide, so you can look it up for yourself if you're interested. Increasing innovation and productivity. This includes, for example, soil sensors, GPS-equipped tractors, and weather tracking in near time to know when, where, and how to plant with unprecedented visibility into operations and opportunities in order to maximize resources, which was one of the dimensions in the poll just now. Second one, greater understanding of environmental challenges, which are obviously interesting and important. For example, prepare for challenges from unexpected weather, which we've seen recently, severe storms, drought, changing insect behaviors, and other environmental factors that impact the supply chain as well. This also includes monitoring the health of crops in real time and creating predictive analytics related to future yields. Third one is reducing waste and improving profits. Through the incorporation of data analytics, agribusinesses gain the ability to answer sales-related questions. So there we go with the third topic from the poll. Through data from a converged platform, for example, not more silos, creating the opportunities to make timely evidence-based decisions. And when we say evidence-based, obviously data is implied. They also gain visibility of pricing, which allows for decisions to be made based on profitability. Again, relevant for your third poll element of the market. And not least, improving supply chain management, something again that is relevant for many industries. The current agribusiness value chain is very siloed. On the one hand, a silo is a good thing for agriculture, but maybe not so much in technology and in the process. And in needs of improvements for communication, for collaboration, and all those elements that go along the chain. Tracing products through the supply chain allows farmers to communicate information to retailers and consumers, something that interests me personally, for example, but also distributors and other key stakeholders regarding product offerings and additional services. To make things a bit more concrete now, I will pick 3 examples from the autonomous machines and vehicle space. Now, if you don't know, GPS have become quite common in commercial agriculture, but current auto-steer technology still requires a human driver in most cases. There's one interesting field of experiment. It's called the hands-free hectare. It's at Harper Adams University in the UK. And it showed, for example, that wheat and barley could be produced by autonomous equipment, and that the cost of retrofitting conventional equipment, so not the one you see on the picture, for example, for that autonomy was less than actually previously estimated. Let's look at 3 even more concrete examples from the last 5 years. If you look at hand weeding, so things you might do in your own garden as well sometimes, that costs around $300 per acre across countries in agriculture. And in most cases, it's not very pleasant work. Autonomous or partially autonomous machines, like the one shown on the slide, have been introduced to increase, on the one hand, the efficiency and potentially save some money, but also protect human health. Now, generally, they don't use chemicals. They are large enough for commercial use, and they are powered, for example, by diesel. The farmer simply creates a map of each bed the robot needs to weed using its GPS system, uploads that into the vehicle through online or a USB key, for example, and then simply puts the robot in front of the first bed and the machine does the rest. Now, beyond weeding, the companies developing such robots, again, may be relevant for you as well, are building their navigation systems to be standardized for any off-road robot, so they could be used for a variety of crop types and jobs or things outside agri. The second example is very similar, but instead of killing weeds, this robot actually goes for the good stuff. Now, winemakers have used drones to inspect their vineyards for several years with high-definition cameras and sensors assessing crop and soil health, etc. This robot, in turn, operates on the ground and is able to make a cut every 5 seconds. It operates 6 cameras, some with infrared sensors, and 2 arms that need to be, of course, managed by smart analytics, and it is simply controlled by a tablet computer inside. In this case, visual recognition is the biggest challenge, knowing where to make the cut. This is actually easier at night, interestingly, because the robot's lights can illuminate the plant, but not the background. Because the solar-powered battery gives somewhere around 10 to 12 hours of charge, the robot can actually operate all night, which again is a difference to potentially a human worker. The third example I'd like to make is independent of the actual crop. As I said before, one approach to reducing farm labor demand, which is high in certain spaces, is to remove the human operator from that farm equipment. But that change also reduces the need for using very heavy machinery or large machines that currently dominate still the commercial farming. Now, swarms of smaller robots could do the work of one large machine while simultaneously reducing soil compaction, which is a real challenge, and cutting the risk of machine downtime. Researchers are also trying to make them cooperate and work in swarms supported by more technology. Here's just an example from one vendor. If they are mapping weeds in a field, for example, the robots will recruit each other to converge on those areas where the weed presence is higher. And that's not something you need to do beforehand. And this may happen, of course, on the ground or in the air. Although GPS signals are generally strong in agricultural areas, one challenge for drones and other farmland robots is coping with patchy internet and mobile connectivity. Research teams are currently experimenting with ultra-wideband radio and other approaches for drones, for example, such that they can communicate without relying on rural 3G and 4G mobile connections. Again, I'm sure this topic will be discussed in a couple of minutes as well. Now, looking at the very select examples I just made, I just pulled out one specific part of where data analytics plays a role. Agriculture, with its actual real and pressing challenges, may pioneer some developments that can also be relevant for you. If you're in an industry that benefits from physical robots, the parallels really don't need much fantasy. For all other industries, including the financial sector, for example, I actually suggest looking at different application fields rather than the agri topics of advanced analytics, and perhaps copying some ideas that might be more advanced than your usual direct environment and your typical sources of inspiration. That does include direct analogies like robotic process automation, RPA, but also applications that are not related to robotics at all. Here's a compilation that I like. It's coming from Roland Berger, all around the central enabler of connectivity. I will actually not discuss the details today, but you can of course take a screenshot or perhaps watch and pause the recording a bit later to dig deeper. Finally, I leave you with this question. Agriculture will not go away. Humans need food and materials, of course. In fact, my research and practical experience showed me that agri-tech may even lead the way in several dimensions. I invite you to ask yourself, dear listener, can I perhaps get inspired by some advances in the field and transfer these learning to my industry? I'm very much looking forward to the remainder of this session. Thank you very much.
Thank you so much, Thierry. Thank you for your presentation. You gave an excellent introduction to the topic. So I think the next speakers, they can absolutely base their presentations on your topics. And I would like to ask the audience, if you have any questions, you can already ask them in the window, question and answers. We will discuss them after all the presentations were given. For the next presentation, I would like to ask Ionut Deaconeasa to give his presentation on the topic Agriculture 4.0, the future of AI in agriculture. Ionut, please go ahead. Thank you so much for joining us today.
Hi everyone, can you hear me, I hope, and also I hope you can see my screen.
Yes, fine, thank you.
Okay, so welcome to my presentation. So my name is Ionut Deaconeasa, and I am the EMEA IoTG Solution Architect, and I am part of the IoTG Sales Business Unit inside Intel. So I'm here today to provide you a quick overview on Intel's strategy and technology for improving the agriculture market. And many of you maybe will ask why Intel, and what is Intel doing with agriculture? So directly, we are not dealing with the agriculture, but behind, through the technologies and through our ecosystem, we are touching a lot of aspects from the agriculture, and you will see this in the next foils. Just trying to give you a little bit of information on what is doable with Intel technology. Okay. With a global population rapidly approaching 8 billion people, one of the ongoing challenges humanity faces is how to feed that many people in a way that is economically and sustainable. And agriculture has changed a lot over the past 100 years. Modern methods of irrigation and land use has increased production dramatically, but with some of unwanted side effects. Those effects include things like depleted soil, nitrogen runoff into lakes and water systems, and increased reliance on fossil fuel. It is clear that smarter use of land and resources moving into the future is both desirable and necessary. But what to do when we need to change these? So in order to drive a more sustainable and efficient food production, we have a clear answer: data, and artificial intelligence. So based on the data we can collect around, the plants, around the environment, we can take some decision in order to increase the production, reduce the waste, and also to reduce the impact of the environment. And the data will help us, on this journey toward agriculture 4.0. Previous, I have mentioned data as the main driver of the agriculture transformation. Data itself, it is useless if it is not used at the right time and the right location. The understanding of data is opening a door for new key technologies. And this is the reason why Intel is interested, on agriculture and many other segments, as I will present in the next foil. Artificial intelligence, one of the technology driving, which is driving the changes inside Intel and Intel products. The way we are looking at the data is changing. we need more autonomous system capable to interpret and take the right decision in real time. Being able to self-learn and to adapt to new data streams is a key toward the smart agriculture of the future. Just imagine the sensors in the field can provide real-time data related to plant disease or pest infestation into an AI system, which can provide a clear and detailed action plan to farmers, or in some situation, really taking local decision in real time on an autonomous basis. And this will help reducing the losses and increase the productivity without impacting the sustainability. The next technology and the driver engine toward the, Agriculture 4.0 is the intelligent edge. So we really need not only to collect the data at the edge, but also to understand the data locally to be able to take decisions much faster. And for sure, if we have so many sensors, so many information which can be released, the networking part, if it is a wireless, if it is a cable, I will call it just networking. So this is an important topic, and we will hear in a few minutes more on this topic. So the flow of data generated by each device is growing. Looking at the autonomous world, the data flow is vital to keep the entire ecosystem in sync. Each part of a system needs to be aware of what the other parts are doing. This requires new channel of communication, more bandwidth, at higher speed, in a deterministic way. By combining those technologies, many problems of our day-by-day life can be addressed. Let's see how Intel is addressing those problems. Let me share some of Intel's strategies in solving some of the needs coming from various markets. As the today world is a data-driven world, and agriculture is not making an exception, the need for more complex, intelligent solutions is driving the demand for more capable compute systems which are scaling across multiple markets in a standard and interoperable way, providing the opportunity for our partners to create new solutions for various vertical segments in order to solve some of the market challenges. Integrating those blocks into an interoperable system and improving the developer experience are key for a sustainable and scalable solution. Intel is investing in creating a seamless experience across our entire product portfolio, helping the ecosystem partners to improve the quality of their products and to be much faster ready for deployment. I would like to mention that Intel is partnering with key market leaders in various segments in order to address and solve the problems and challenges of each segment. This foil is offering just a glimpse of the market addressed by Intel Technologies through the ecosystem partners. Over the next 3 foils, I would like to provide some specific use cases on how artificial intelligence holds the promises of driving an agricultural revolution at a time when the world must produce more food using fewer resources. The first example is related directly to the agriculture and growing plants. So pests have always plagued farmers. Some 10,000 years after the invention of agriculture, locusts and grasshoppers and other crop-devouring insects are still a big issue for farmers. But AI gives growers a weapon against cereal-hungry bugs. By using visual inspection methods combined with weather information, it is possible today to identify in real time where a swarm of insects will land, warning the farmer and helping him to remove the pest from his field. Another aspect impacting the production is irrigation management. Water is a very costly factor for farmers, and the optimal utilization is a key factor moving forward. This optimization can be done through a dynamic irrigation system that uses sensors embedded in the soil to monitor the level of moisture and then waters plants accordingly. As we are looking toward production, higher production and producing healthier food, we must consider also the aspect of chemical treatment of the plants. Instead of spraying the entire field, we can rely on data provided by sensors, could be a visual sensor, for acting only on specific affected areas in order to limit the potential negative effect of the quality of the crops and the environment. The next example is related to aquaculture. The growth demand for healthier food is impacting also the aquaculture segment. Artificial intelligence is playing a key role in improving the entire process behind fish farming, leading to a higher quality products with a minimal impact on the environment. Depending on the fish species, the water temperature must be monitored in order to create the optimum growing environment for the fishes. Besides temperature, oxygen level is also a critical aspect which must be controlled in order to avoid losses and have a healthy product delivered to the market. pH value have a direct impact on the quality of the fish and the environment. So this is also a very important criteria of monitoring the environment. Complementing the data mentioned above with special underwater cameras, which are monitoring the fish movement, possible health issues, and food delivery, we get the full visibility of the fish growing condition, improving the production and reducing the negative impact on the environment. Artificial intelligence is a key enabler for the aquaculture of tomorrow. The last example I will provide to you is coming from the livestock. Even the livestock is getting a big benefit out of artificial intelligence. Monitoring the vital parameter of the livestock, combined with the data around, like weather, food availability, dirt level, provide a good insight on the measures needed to correct or improve the situation so that the livestock does not get affected and the impact on the environment is minimal. As I shortly presented to you, the artificial intelligence is a key ingredient when moving toward agriculture 4.0. And we need to work together, creating the technologies and solutions which can help farmers increase the production, create better quality products in a sustainable way. Thank you very much.
Thank you so much, Ionut. Thank you for your presentation. That was a very good overview of use cases. So we got livestock, we got agriculture, and we learned that the artificial intelligence is very important to actually deal with the big amount of data which is coming in. For the last presentation, before we are going to the question and answer session, I would like to ask Alexander Lehrmann to give his presentation. His topic is more data, less pesticides, the value proposition of 5G enabled precision farming. Alexander, please go ahead. The floor is yours. Thank you so much.
Thank you so much, Alexander, and honored colleagues here. I want to pick up where most of you already touched upon and really focus and hone in on like the enabling technology behind all of these new possibilities and opportunities. And really, I think, 5G is one huge building block that can help us to become more successful in driving these solutions to the marketplace. So I'll start with the technology a little bit, and then I'll get into some of the use cases as well. And obviously, no slide from a telco operator that shows you the coverage, but I want to make that point that 5G is here. It's here to stay, and it's a viable technology available to drive transformation in many industries. And Switzerland is blessed anyway that we are quite ahead in terms of rolling that technology out. And clearly, as we look at agriculture, it is finally an opportunity to bring broadband internet access also to those rural areas where you typically find the agricultural use cases that depend on that connectivity. So that's definitely something that is going to drive us forward and help accelerate the pace of change. Now, what I would normally do is, if we had a physical meeting, I would ask my audience, what do you know about 5G already? Does it give us smaller smartphones? Does it give us a mobile broadband? Does it give us more capacity? Or is it really all about the lowest possible latency? So like real-time applications, and I'll give you the answer straight away. It's obviously answer E, so it's everything from B to E. I'm not sure it's going to be smaller smartphones. Actually, the smartphones get a little bit bigger with 5G because we have more data to look at. But it's really those three elements, unlimited data transfer rates, almost massive capacity without draining performance, and then the possibility or the opportunity to drive real-time applications. And every mobile phone generation had really its use cases. 4G, the last one, was really about the mobile internet. 5G is the enabler for really the Internet of Things. And that is obviously a cornerstone to many of the use cases that we've seen. And my fellow speakers here that presented before me, they had all the use cases that really did, use the Internet of Things to drive the case forward. And that is just going to be much more enabled now with this new technology, and more applications are possible that weren't possible before. So as I look at IoT, it's really, and sorry for the German slides here, but I kind of reiterate what I'm saying here is IoT is really a capability to understand your environment, to understand it in real time, and then to possibly control it. And in agriculture, this basically means, to understand what's going on in your agricultural field, to understand what's going on with your animals, to understand what's going on with all of your operations, and then to react super fast and make the right decisions to maximize the outcome. And 5G then obviously is the technology that allows you to transport massive amounts of data very fast with very little latency from many devices or even animals across your environment. And that drives transformation in all the industries. I always find it hard to find an industry that is not being transformed by the capabilities of 5G, and agriculture or smart farming is no different there. So let's get right into this. Innovation is already happening. We did a lot of interesting use cases with 5G and the agricultural sector, just because also it was so symbolic for Switzerland and really iconic to some extent as well. But it's recognized, it's happening, and there are many stakeholders by now that do see the value in it and the value in using new technology to drive the industry forward. And I think the main message that I want to deliver is really that we finally have an opportunity to to kind of solve seemingly contrary objectives or pursue seemingly contrary objectives. And that means in agriculture for many ways has been sort of notorious for not being able to increase food production at the same time be operating sustainably friendly. But now that's possible because of those capabilities that I just described. And some of the use cases that we've been hosting in our innovation lab, they show us we can reduce pesticides massively. We can actually eliminate them altogether because we've got so much more data to work from. And we can treat our animals much more friendly. And by the same token, they provide us with more milk. So interesting from that point of view to do things that haven't been possible before. IoT in agriculture, it's use cases out there are many, and we've just seen some in the previous presentations. It's really taking, deploying sensors, taking that data, running it through some kind of an intelligence, like producing a map in this case on the slide for fertilization purposes, and then selectively deploy fertilizers. That's already an interesting IoT solution and drives very great efficiencies going forward. And really what it does is it augments the capability of the farmer, because so far it's all been based on gut feel. So the farmer knew its land, knew its animal stock and everything else, and made decisions based on that. But now it's really complemented by quantitative information, quantitative methods, and obviously data. And I want to show this, very nicely on one use case, again, that we've been kind of developing over time now and have actually deployed in the field as well. And that's the connected cow, and call it as the Internet of animals, right? We talk about the Internet of Things, but it's things means processes, means machines, means environments, but it can also mean animals. And these animals sort of have a sensor around their neck. We take the data from that sensor, which is vital data, which is health data, send that over the network to the farmer. The farmer can, independent of where he is, really see what the situation is with the cows and take immediate reaction. And that is good for the cow's life, as well as to maintain health, and then in the end also have these cows deliver more milk over time. Just to give you a little bit of imagery on that topic. So this is how the sensors look. We also complemented it with a camera, so there's even a visual inspection opportunity for the farmer. And again, it's a fantastic thing that really takes into account, to monitor health of your animal stock. You be on top of what's going on, intervene when something's not going on and going well, and at the end up with a greater milk production as well. And obviously, you know, the networking technology can be the enabler for making that happen. This is how the data looks actually. Not only it's good for health and understanding how the animal is moving, you know, what the digestion process is and what temperatures are, but it actually goes even further. What we show in this graph here is we get a glimpse into understanding estrus. Now, this was for me a new term as well as an ICT guy in agriculture, but understanding estrus is very important to a farmer because that again, you know, improves the life of the animal and allows the cow to provide more milk over the lifetime. And now with the data that we have available and understanding estrus from the data that we actually see is much more healthier, because the normal procedure is to just use antibiotica or hormones to the animals to really get that insight into estrus. And here, just by reading data, by collecting data over time and extracting information and insights from there, gives us that you know, cutting edge insight really to avoid treating the animal with something that shouldn't happen. So really cool case. And now to the actual case that was part of my headline here, which is to selectively treat agricultural fields with pesticides and use data to improve that process. This is essentially how the workflow looks. So we've got drones flying over agricultural fields. The drones have a camera. The camera scans and films literally all that ground information, sends it over the 5G network into a dashboard, essentially in the cloud. Here we've got analytical software, an algorithm that's running, and that is analyzing that data. And because of artificial intelligence, that algorithm can decide what are good crops and what are the bad crops. What is the weed, right? And then you send that information back into real time to the deployment machine, whether that is a tractor or an autonomous robot. And then that is it. The machine can selectively treat the weeds as you see it on the right-hand side of this slide. In fact, this is the real experimental setup that we have in our innovation lab, and we can let the drone fly over those artificial plants on the top photo, and then the algorithm returns us the lower hand photo where you clearly see where the weed has been identified. And you know, as such, we get sort of a digital map of the weed and can tell the machine to selectively treat it and you know, make that a very efficient process. And all of that is just possible because you're using state-of-the-art communication technology and combine it with other tech like AI in this case, computer vision and all of that, and really make it a very interesting system, which then, you know, as you see on this slide, can result in a vision to deliver agricultural, you know, procedures now much more as a service, in a way that a farmer just needs to decide, so what's the size of my agricultural fields that I have to treat and how long do I want to treat them? And then you'll just buy that service from a service provider, which in this case, you know, we've got quite an interesting array of companies lined up to drive this solution to the market. But it could be offered as a service, right? So no particular skills needed on the side of the farmer, but everything really delivered just by, you know, a per square meter basis, basically. So with that, just the last note, you know, in my role at Sunrise UPC, I can play around a lot of things, a lot of new stuff, a lot of innovation items and areas, and we'll do this as the smart farming case that I just went through in our 5G Joint Innovation Center that we operate together with Huawei at our headquarters in Zurich. And with that, I think, Alexander, I can hand it back to you.
Thank you so much, Alexander. That was very interesting, and I won't forget the term Internet of Animals. That will stick. Thank you so much. So before we go for the answers from the audience, I have a very general question. Maybe everybody can lean in, and that would be in terms of low-hanging fruit. You know, where you see actually are low-hanging fruits in terms of applications to agriculture of data-driven analytics and artificial intelligence, and maybe also why it's not used, why the fruits are not picked, these low-hanging fruits, and also maybe is it the right strategy to go for low-hanging fruits? Maybe it's better to just you reorganize the whole system and maybe build up new farming. So what is your maybe your perspective on that? Maybe Thierry, can you give us some perspective on that?
I think a case that is quite advanced is crop health or plant health on different levels. Now, the problem here is a little bit the order of magnitude. Typically, what you would do, you take a satellite image or a drone image or land-based image and try to find out which of your apple trees or any crop that would grow there would be healthy and not, and try to either eliminate them from the bed or the field, or try to treat them if it's not too late. That's something you can do with current, both the state of machine learning, but also the state of vision and cameras quite easily. And it's like a semi-intelligent case. So you would probably still, in many cases, send a human to actually treat the plant or do something with it. Now you can combine that with some of the cases I just shown with those autonomous or semi-autonomous robots. If the GPS signal is good enough, and you can leverage Alexander Lehrmann's setup for 5G, for example. So that would be one. Why is it not used more? I think it's more of a human hurdle than a technology hurdle, like in many other technologies we discuss at the moment. First of all, the relationships in agriculture are based on pretty small environments. So even though the farms are getting bigger and are consolidating, you have typically relationships to a small group of other people who are your consultants or the people you trust. That is still very much the case. So many farmers have their own solution for their own setup. And that might be the reason why there's no general fast growth or evolution on the development. There's a couple of more, but I don't want to take all the airtime. So I'll stop at this time and perhaps hand over to or back to you so you can further.
Yes, thank you, Thierry. Ionut, is also that your observation, maybe why low-hanging fruits are not picked? Is it something maybe the human, let's say, you stick to the behavior you always had and it's hard to innovate there, or why are low-hanging fruits not picked there?
So there are several factors we see here, so it's really, I will agree with Thierry on the group growing and really understanding, okay, what is good, what we need to handle in the field. But when I'm looking at the, geographical distribution, so if I'm looking toward US, where you have a big piece of land, so maybe they are more advanced into that from this perspective. It's just because, managing a bigger or a huge amount, of land. So it is quite complicated doing manually. So then you can you should rely on this kind of satellite images, or drones or planes images. And then I think they are more advanced. They see this benefit, and already you have a lot of farmers which are relying on GPS. So even when they are sitting in the tractor, but at the end of the day, the tractor is driving alone. So it's kind of autonomous driving. So the technology is there. They are using it. If I'm looking toward Europe, where the farmers have just small pieces of land, so everything is more I would say like a puzzle, so then the investment for this kind of solution is a little bit high. So maybe that's the reason why in Europe you will see those kind of investment, only at the big farmers level. You don't see it as well established as in US. And then moving toward China, where again they have big fields, with monoculture and so on. So definitely we see also the adoption of the technology, the adoption of this kind of intelligent solution is more advanced. So definitively, there are some geographical factors, which are related to the surface, to the monocultures, and then all those aspects which are influencing the timeline, or let's say how fast, some farmers are adopting the new technology, and other farmers are maybe a little bit pushing back and saying, okay, so I can still manage this manually. But definitively we see the growth, and moving forward, this will be, let's say, a growing market. And with this, back to you.
Yes, thank you so much. Alexander, maybe from the Swiss perspective, is it already cost effective to use your service? I mean, you're probably in the pilot phase, but when I think of Swiss farming, I think of you had the house. Maybe the Swiss farmers, they know every cow by name, you know, so that is something, there's a quite a different business than in the American Midwest. So what is in terms of cost effectiveness? Did you do some calculations there, or are you saying this is currently like the early stage where this is not as important for you right now?
Yeah, I guess it really depends on the solution, right? You know, so if I look at the two use cases that I presented, the connected cow solution is probably one that is very simple to turn around and to implement, and is not costly at all. I mean, literally, what the farmer needs is connectivity. Obviously, he needs the access to the cloud, and he needs those sensors. And then he's actually done, right? So I think here this topic of, you know, we don't necessarily need it because our land in Switzerland is not as large as it is in Australia or in the US, where you actually can make big use of these kind of things. I think you already get the cost effectiveness there already, even in our topologies in our country. The other use case, the one that I showed around the detection of weed, that's probably a bigger one. It's very early for us to tell because we're still in sort of pilot phase and you know, finalizing the algorithm and these sort of things to really get a view on actual cost. But I think, you know, then it's also a question of the business model. And what I showed in terms of turning this into a service that somebody like Fenaco can roll out to the entire farmer population is a new business model, and then makes it affordable, makes it cost effective, even for farmers in our environment. So it really depends, I guess. And the starting position is not bad, I don't think.
Right. I would like to come for a question from the audience, and that is in terms of, we already started to discuss the comparison between countries. So which countries are further in using artificial intelligence and data, maybe not only because they have big plots of land, but maybe because people are also like maybe more, let's say, attracted to new technologies. So how is Switzerland faring there, Alexander? What do you think in terms of, you said 5G, we are quite ahead, the country is quite ahead to other countries, but in terms of adopting data and artificial intelligence, is there more potential than maybe still to let's say, improve on that area?
I think you just said it, there's more potential. I mean, if I look at it broadly, not just agriculture, then clearly we're not yet the AI leader, if that is something we would like to see or would like to see more progress on. You know, the progress in AI happens in China, in the US, in those countries, which really, it's literally a war on AI, I would say, you know, from my point of view. Agriculture, I think we're there at the starting point. Our view is certainly with the rollout of 5G, bringing, you know, fiber through the air, even into those rural areas, into the agriculture sector, you can now start to make more use of it. I think it's always a combination of having like this performing network infrastructure, plus combining it with AI, with analytics, with machine learning and computer vision and all these other good things. I think now we have the fundamentals in place. So now we can start building on it and really making sure that we're not left behind.
Thank you so much. Ionut, what is your view on the international comparison? Which countries are maybe further ahead, maybe also like in terms of government support, in terms of society, which is adopting technologies faster?
Oh, so this is a very good question, and it's very political. So maybe I'll just try to answer from a technology perspective, but definitively, you know, we see also China and Asia adopting much easier the technologies and much easier, you know, this kind of, you know, access to the data, because at the end of the day, if we're looking toward the European Union, so we have also a lot of protection of the data, and before releasing the data and analyzing the data, we really need to be sure that, you know, there is no personal data. So even if we're talking about agriculture, you know, but monitoring a field, you know, or monitoring let's say a farm, at the end of the day, if I will use any video mechanism, you know, so definitely I need to be sure that there is no personal information registered there. So saying that, you know, China is advanced because they are adopting very quick the technologies. They have also big farms, and they are really focusing also on the kind of monoculture, you know, type of agriculture. Definitively Americas, and if I'm looking here at North America, so it's not only US, you know, it's US, Canada, Mexico, even Brazil, you know, they are quite advanced. But definitively in Europe, I see also some progress. So if we are looking at really then the big farms for crops, then I mentioned China and Americas are in the front. But if I'm looking then at other aspects, and I was presenting the aquaculture, so Europe is ahead of other countries, and if I'm looking to the Nordic countries, Norway, which they have a big industry around, fishing. So definitively, so they are at the top of the spear at this moment. And yeah, so it's quite tough because you have agriculture, is having so many aspects, and just we need to split it a little bit, okay, which kind of aspect we are looking for, and then we can create this kind of, categories between the countries and so on. But definitively, every region is, let's say, leading on some aspect on the agriculture, depending on, the, let's say, surface of the farm, depending on the what kind of topic from the agriculture they are touching. And also, if I'm looking toward, the kind of chemical and usage of the chemicals to the industry, so I think Europe will be leading because, we really need to control and coming back to what Alexander was mentioning, really detecting and acting only on the right spot. So this would be something that Europe will lead definitively. And I see we already have some advance on that side.
Right. Okay. Thierry, what is your perspective on this international comparison? So we saw that maybe Europe, we have to be more careful when we do agriculture. So maybe it's actually quite good to use more data there. But other countries maybe are faster in adopting new technologies, or maybe more commercialized. What is your experience there? How would you draw the comparison?
Yeah, you brought in quite some dimensions, being careful and government support, for example. So on the one hand, yes, we have to be more careful if we want to do agriculture. On the other hand, we're also more careful when we release new technologies and laws. And we have this culture of Vernehmlassung, and which requires a higher maturity to go out with stuff. The good news from my perspective, so I would subscribe to everything that my co-speakers just mentioned. I'm not going to repeat it now. Good news is, from my perspective, AI as a field is still so young. If on an index of 100, we're at 0.001 or less, that every country can still lead or co-lead the field. I would appreciate if in less risky environments, the countries would actually work together for creating good solutions that help tackle those global problems. That's in part a political thing, so not for me alone to decide. But even a small country like Switzerland can help lead here, and should help lead here, given we're so high on innovation indices and stuff like that. And that is true for agriculture, but also for other industries that try to use the power of AI, machine learning, and related words.
But would you have any specific tips, like in what areas maybe, let's say, the government or academics or large companies could maybe go forward in Switzerland?
I think one culture that we can still improve is the one of rapid prototyping on a slightly larger scale. So if we allow for stuff, if it sounds really unrisky and is very well controlled, on the one hand, that's probably a good thing, especially when it comes to touching, food and living material or livestock, for example. On the other hand, the whole culture of rapid prototyping around AI and maybe going a little bit further while still managing the risks could be something that we could do better from my perspective.
Good. Okay. So I think we don't have any further questions. So I would like to thank the participants, thank the panelists for the presentations and the time to give us a great insight into this important topic, and thanking the audience for listening to us today. You can the webinar is recorded, so it will be available on the website fuw-forum.ch later on, like the other installments of the webinar series. And thank you so much for joining us today, and have a good evening. Thank you so much. Bye-bye.
Good.
Thank
Thank
you.
you. Cheers.
Bye-bye.
Bye-bye.